The sliding filament theory is the believed and scientific way muscle contracts without shortening but instead sliding once the impulse reaches the sarcomere. It begins once the calcium reaches the actin, causing the troponin muscle to change shape and the tropomyosin to move to a different position. This therefore leaves the binding site free on the actin, allowing the myosin head to extend out and bind to it. Once the myosin is binded to the actin, creating a cross bridge, the ATP is released, changing the muscle to a relaxed shape, resulting in a power stroke, pushing the actin across. The myosin is then released once a further ATP is binded to it. This is repeated as the ATP gets broken down into ADP and phosphate, causing the myosin head to extend again. This will constantly repeat as long as calcium is present, and will result in responding to the stimulus with a movement, e.g. a kick of the ball. Within this process, there are also different types of bands that could be looked at. For example, the H zone, which is full of myosin, contracts when the sarcomere is reduced and becomes smaller when actin overlaps it during a power stroke. This is almost mirrored with the I band, as although it contains thin filaments in contrast to thick, it also shortens in contraction. This differs with the A band, as it remains the same length during contraction. There are three types of muscle contraction: isometric, concentric, and eccentric, that are vital in sporting scenarios for athletes. Firstly, there is isometric, which is a type of muscle contraction that occurs when holding something in front of you. It does not lengthen or shorten, but remains at a constant length. This is highly important in sports where the athlete is expected to hold a piece of equipment, e.g. a tennis racket, for a prolonged period of time, as the muscles contract in order to provide a sufficient force to keep hold of the racket, despite there being no movement. Concentric contractions differ from this, as they occur during a movement more specifically, as a muscle shortens in a contraction, like flexion at the elbow, in the biceps brachii. This could be seen perhaps in training for a sport like boxing, during free weights on the biceps, as the arm flexes to bring the weight on and give it tension. Finally, we have the eccentric, which is almost the opposite of concentric, as it occurs when a muscle lengthens in contraction and tension is produced. Similar to concentric, this could also be found while training for a boxing fight, as a workout for the biceps. However, in the lowering phase, as the weights are lowered, as it would cause the biceps brachii to lengthen and therefore undergo eccentric contractions.